And moreover, in the context of the Hadoop and all the other ecosystem tools, how this Spark is going to perform, okay, in terms of time and as well as the space utilization. At the same time, we are going to make use or we are going to study some of the important aspects of the Spark. So like RDD and data frame, all these kind of the terminologies, right? And before talking about this Spark and all the other things, let me walk through which are all the aspects we have seen so far, so that as a glance, as a recap kind of thing, we can talk. And before that, the today's session objectives. So just I'll be talking about what exactly Spark, so Spark basics, and thereafter the second thing is um, Hadoop versus Spark. What is the exact relationship between those technologies? And Spark RDD, which is the basis for Spark understanding. Next is Spark data frame. And this is, of course, friends, most important and useful construct because all our Spark-based implementations, like PySpark and as well as Scala and Spark SQL, okay, all these kind of things, all are revolving around the data frame construct only. Okay, so this is how you see the orientation of the Spark in the context of usage. Okay, so and coming to the things we have discussed so far. So just we started with the very first thing, the big data and the terminology, and thereafter Hadoop is a glance kind of thing, is a problem of storage and access mechanism, storage and access mechanism. And second thing is Hadoop is nothing but the solution. Okay, for the solution in terms of framework actually. It uses a kind of the framework and it is going to give a solution for storage in terms of Hadoop distributed file system and in terms of process, which is MapReduce. Okay, that is the basis. And coming to the other things, in Hadoop versions, actually various versions are there. These things are there. And of course, in 1.x, however, we are having HDFS 1.0 MapReduce version 1. And in 2 and 3, so just we are having HDFS 2.0 MR2 on top of this add. So those discussions we've had. Like in 1.x, we're having the problems of single point failure, job tracker overburden. And those things were solved in HDFS 2 and as well as the MR2 in terms of MapReduce 2 and add, which is providing active name node and as well as the passive name node. And there is a separation actually. Cluster resource management is one thing, and there are job scheduling and job related aspects are another thing. Because in this case, all are same. So only the job tracker need to take care about the cluster management, job related aspect, all those considerations. And once that discussion is over, we have seen block based storage. So with replication S3. Okay, so that means based on the requirement, suppose file one requiring 500 MB, provided 256 MB block size is there. Then in that case, I need two blocks. Such blocks I need three. So total six blocks are required. So based on this block storage, the data will be shared across the nodes. And coming to the other thing, master slave is the basis for our Hadoop. And there, a simple analogy, there is a name node which is maintaining the metadata, and there are nodes connected to this data node, one, two, like data node n. Okay, so status update and following the instructions of master by slave. Okay, these things make use of the convention of data node and name node. Data node, of course, which is a storage, the actual entire data will be stored in data node. Name node only maintains the metadata in terms of file locations and all the replications, all these things. Apart from these kind of the conventions, so just we discussed on the resource manager and as well as the node manager, and then we are having the container, application master, and thereafter, friends, just we having a map task, a reduce task. Okay, these kind of the conventions we have seen. And thereafter, the map reduce phases actually. Yeah, if you refer the map reduce pages, these pages refers four things actually. First is the input split phase. Second is the map phase, which is converting the data into the key value pair. Third is the shuffle phase. Last one is shuffle in the sense sorting, all these kind of the considerations. And last one is reduce phase, aggregation of the final result. Of course, we observed that input split phase is a framework activity. Automatically, whenever you give the input, and it is going to split. And this map phase is the developer activity. Again, this shuffle phase is also framework activity because we need not write any logic for that. It automatically starts and arrange the data. A reduced phase, again the developer activity. So these four phases with some examples we have seen. And once this is over, just we discussed Java-based MR submissions. So just what we have done in the web shell, just I create a kind of user-defined jar, maybe mr1.jar. Okay, this is the jar which you need to export. Okay, with the help of all these things like mapper class, reducer class, and driver class. Apart from that, you need to specify the package name, com.sample dot driver class name, maybe word count. Okay, this thing and the input you specify. Maybe input I am giving IP HDFS, input HDFS, output HDFS. Like that you can specify. The other way is if ready-made jar is available. Okay, dot jar is available. Then in that case, as a Hadoop developer, what you need to do is just you need to specify one command unzip -l. Assume that here I am having mr2.jar, mr2.jar. So after giving this thing, guys, you will be getting all the package name and as well as the class info like that. So based on this thing, after picking up of this particular data, you can as usual submit the corresponding job. Okay, so this is the Java based. And next we have seen Python based MR submission. Okay, here what we have done, same in the web shell is a long command actually. So for that, we have taken Hadoop ZAR. There is a predefined streaming ZAR actually because there is no ZAR concept in Python. So just what we need to do is the streaming 3.2.2. Okay, just we convey the information of just I'm using the other programming language to submit the job, and I should give the files information, maybe map1.py, comma reduce1.py, and explicitly I should mention the mapper map1.py and reducer reduce1.py reduce1.py. Next is friends input. Okay, there is no input word in Java actually. So directly we will give the name of that input. You need not mention even input or output, something like that. Because always the native languages, okay, reduce the uh, usage of the commands. But whereas if I want to handle other programming languages, then I should give scope all these kind of things. So input as usual IP underscore HDFS, and thereafter your output HDFS1, because logically existing things cannot be taken. Okay. So likewise, the Python way of doing the things we have seen, and in between we executed certain commands of the local file system. Okay, like ls, cat, vi, all these kind of the commands, and related to HDFS command set, many we have seen to notify something, because while you're referring this Flash shell, you should be able to recollect all the things, guys. That is the idea. So we have seen some kind of copy from local, copy to local, uh, move from local, just to have seen some put command, get, and thereafter something like set replication, copy, move, um, then mm, RMR, RM, like that we have seen many command frames. Okay, that is one thing. And other tools like WinSCP as a part of copy the data from a local machine to cluster actually. That cluster we are having, cluster local file system. Okay, we don't get direct access to the HDFS. If you want to directly copy the data into HDFS, the option is simple: view portal. Okay, just directly from the local machine directly to Hadoop distributed file system, I can upload the data. So this is one genre actually. So like all the kind of the things, and thereafter I have introduced some concept of the Hadoop ecosystem. There are certain tools we observed. So HDFS I am having for the sake of storage, and I'm having the map reduce for the sake of processing, and of course MR1 is there, MR2 also there. Both we have seen, and next is AR, which is cluster resource management, and then we observe some Hive, which is a kind of the ETL. No, we have not seen. Soon I will introduce this thing also, guys. 1 or 2 hours required. Okay, just I will introduce this thing. A simple analysis. data analysis tool. Because now we are not using this tool. That's what I'm not giving that much preference. But the Hive we are using, that's what I scoped this. And thereafter the scoop, so RDBMS data to HDFS. And scoop guys, mainly the problem is while installing and after installation also, maybe some of the commands may not work, like import or all these things. Then in that case, just you go with your local host, something like 3086, some port is there while importing this thing. And moreover, that driver also explicitly, some of the machines may not take that, the driver. The driver is there, no? Like com dot JDBC colon MySQL driver, some driver name is there. Just you scope the driver. And most importantly, get the host name, friends. Host name may be available. Sometimes it is taking the local host, or you have to give the IP also. Okay, because this is the IP, whatever the host name. Sometimes Scoop allows us to directly interact with the local host name along with 3086 kind of port. It all depends, guys. There is no common solution. Like in cluster, we follow some kind of the convention. Whereas in case of local host, all the Cloudera kind of installations, we may face some difficulty. But according to the error, just you resolve that. Maybe you need to focus on the driver in for making and this IP localhost colon 3086 or else direct IP. Okay, 122 dot something is there. No? In that way also you can make use of the connection. Okay, so while importing and one more thing, uh, the data types and all those things are also very particular because this is a type safe kind of thing. Just have a look on those kind of the conventions also. Okay, because as based on the corresponding error only, we should make use of the appropriate logics and accordingly we have to solve the errors. So that point you observe. And once this within the scope, we have seen many considerations, guys. Okay, like once a glance, just on the way, no? List tables, list databases, and thereafter we have seen import a single table. Actual excellent tool, guys. This is okay. And import multiple tables or all the tables, and we have seen some export HDFS to MySQL table and eval function. Okay, evaluation of the corresponding things. And by the way, this Hive also, let me repeat which are all the constructs we have seen in a way. Uh, Hive basically we have seen a typical ETL and their internal table, external tables, and external table data to HDFS storage and table data to a local file system, table data to local file system. And thereafter, we have seen table 1 to table 2 storage, a load data. Either I can select the local file system or Hadoop distributed file system. These things we have seen. And then the other thing is, guys, just we have described row, tables, all these things as a common kind of thing we have seen. Next is related to partitions, which is most important topic. And thereafter, we have seen bucketing concept in terms of clusters. And after that, just we have seen some concept of indexing, compact, and bitmap index. And thereafter, Hive GUI, Hive functions, and joins. Okay, so these are all some of the aspects we came across while talking about the Hive. So scoop wise, we have seen these are all some of the considerations, friends. If you guys want any repetition, or if you want to have some discussion, okay, out of these things, as a kind of 2 or 3 minutes discussion, I am holding here. Okay, you can ask me any doubt, or you can add some more points based on your observation. Suppose if I want someone to summarize, let me pick some person who can summarize. Um, Harish is there, no? Harish, can you talk
Yeah,
something on that? Yeah, hi Harish. Overall experience with these tools. What is your observations? Or just I'm asking you to summarize in a 2 or 3 minutes. Yeah, how do you feel, and what is your observation or takeaways kind of thing? Yeah, at a glance, Harish. Yeah.
yes, from starting to till now, we introduced some like big data terminology. And first of all, the tools we used, like Hadoop distribution system, and the which we introduced some the storage process like MapReduce and their process also. And thereafter, we seen some the MapReduce one to and the yarn process also. And the tools next is I think we
Tools, huh?
use
Okay.
some metadata also there. Uh, there Python and Java, which one we prefer the language, Python programming language. Then
Okay.
WinCP and the Hadoop based system, basically comparison from Hadoop 1 to 3 also. The MR1 process, the MR2 process also we seen that. In Hive we seen the ETL process, uh, the like how to uh, drive the data from a source to a data warehouse.
Correct. Okay.
And scoop import data from the localhost driver, that also.
Yeah, yeah, good, good. Okay. So, just as a summary, guys, just we have seen few aspects related to the Hadoop ecosystem. Now we are going back to I mean, the storage levels and how these things are having some issue, and how these things can be resolved in the Spark orientation. Okay, so that is the understanding. And moreover, one good news is heavy programming won't be there in Spark, friends, actually, because why people love this Spark is, let me introduce that particular thing. Uh, if you see this Spark kind of thing, as a developers, the very first important thing is the simple coding, the constructs provided by this Spark, very simple, and of course, in-memory computing. Okay, due to it's in-memory computing, just we are making use of the Spark, and moreover, Spark provides batch, interactive, and iterative. Okay, so that means batch in the sense, of course, while referring the map review high. scoop. In all those things, the basis is batch processing. Of course, those things, however, you can implement them. And interactive, okay, something like the streaming or real-time analytics. Okay, these things can be done with the help of the Spark iterative jobs. And there are certain repetitive jobs where I want to achieve something monthly payroll or such kind of repetitions are there. Okay, there is no need of user intervention. Directly the user can iteratively perform the activities. Okay, so that is how you see the Spark capacity trends. Batch wise, interactive, iterative, all these things are thing. And moreover, the in-memory computing is main base for the Spark running actually. Here the point is in case of the Hadoop, so just we are having that every time, maybe while running the map reduce, even the temporary results also going to store in um, Hadoop distributed file system. You imagine guys, while running a huge job, after splitting that input information, after taking that map key value pair, again the entire map is going to store into the Hadoop distributed file system. Again, it should be fetched from that, and it is going to launch the shuffle phase. And from that shuffle phase, again, it is going to store into the Hadoop distributed file system. So there are multiple IOs, context switches, where the data is going to store and plug into Hadoop distributed file system and going back and picking that data. Okay. Though we are having a speculative execution, but this every time disk based writing and reading cause some kind of the time implication and as well as the time incur. Additional time should be incurred on that operations. So the complete changeover is there in Spark in terms of in-memory computing. Okay. So let us see the orientation of this Spark. Just let me see this thing actually. 1 minute, guys. Yeah. Okay. So I'll be sharing this thing with you. Just a minute. Okay. So if you see this out of these things, just we have seen many times this portal. Um, if you click on this Cloudera Manager, so we are having all the components with us. Especially, we are talking about the Spark. I'll give you a brief history. Already we have seen, guys, this Spark in what way it is integrated with the app. Okay, so because that time, Spark is bounded with Mesos actually, but Mesos is not handy. It's a big failure. So people started using Spark on top of the app. But one more demand that time the developer put across the designers of this Spark. So can we have Python version? Can we have some other R version or Java, whichever? Because they basically released Spark in terms of Scala. Okay, because Scala is a programming language which is a default programming language of Spark, which is supporting both the aspects in terms of um, functional programming and as well as the object-oriented programming. Now, out of this, just to see this Spark, click on this. Just will be leading to some kind of interface. And here also, one of the important point is as we are running Spark on top of the ARM. So obviously, we'll be seeing this history server host. These things are common. And of course, Spark is having the web UI. There is no separate UI. In case of ARM, we have seen two things actually. One is the resource manager. Second is the history server. But whereas in case of the Spark trend, generally one web interface is there for Spark. This is the history server web user interface. Click on this, and as usual, just you can make use of this convention, and then okay, so just you can refer this and make use of this. Okay, see guys, this is the Spark history server. Okay, so the, here the idea is bigger jobs, maybe multiple jobs. If you see from various users, it is recording every job information. And if you see this history server, just it is event logs and all. And of course, the thing is there is a nice integration between Spark and as well as the HDFS. Okay, because Spark can be integrated with the Hadoop distributed file system for some other reasons. Okay, the reasons and all I'll put across before launching the actual Spark architecture and RDD and data frame. It is mandatory to understand how Spark and as well as the Hadoop are integrated and in what way we are enjoying the benefits of as a complementary kind of thing. Because some people say after the advent of the Spark, uh, Hadoop is no more. No such kind of the convention. No technology. See, any technology which is having the capacity of serving the users and which is having the potentiality of serving the companies, there is no end for that. Okay, so like Hadoop is not an excuse for that. So and moreover, one of the biggest challenge in analytics is heavy data storage and processing. So definitely to achieve the better analytics, we should have the most maybe Google. If you see, that's what I asked one question in terms of Hadoop distributed file system MapReduce. Within that Google MapReduce article itself, they clearly mentioned so how they have how they are making use of this huge data and how they could able to project the data in a perfect way. Even if you type anything, immediately you will be getting the entire data. See, just if you go to here and if I'm making use of the corresponding entries. So in the of course this is the one search engine of course, but whereas even though all the search engines, Bingo and Microsoft or whichever we are talking, and Google, all these kind, definitely they're all gives us some kind of narration. Okay, just to type this thing, if you type the proper name of that technology or whichever, obviously you are going to get the corresponding information. See, all these kind of the data and all. And majority of the time, the first page itself, friends, we are having our requirement. Okay, so that is the advantage. How they are pulling the data, how they are making use of some kind of the convention. So this is the advantage of pulling the data and usage of that heavy data for our applications. So Spark also providing machine learning libraries. I'll introduce one by one. This entire week we'll be using, we'll study RDD and data frame, and we'll slowly introduce some kind of the MLlib kind of the libraries. Excellent genre, friends, actually. Okay, because the main complaint against Hadoop in terms of developers context is even some people given that in writing also. Okay, while I'm going through that assessments, your submissions, even they mentioned some complex coding, map reduce, all these things. Though we're having the high, but the batch processing is a kind of limitation. Okay, so with this, just we are having many avenues and many, of course, issues. If they are coming, then the new technologies are going to resolve that particular issue. Okay, so such kind of aspects, plenty of aspects are there where Spark resolved those kind of things with the power of programming and in-memory computing. Okay, so just if you see this, this application is having the DAG friends. Actually, if you see the ARM kind of thing, there are resource manager, node manager, container, map task, reduce task, application master, all these things. But the terminology wise, if you observe, there are certain aspects, friends. Actually, jobs, which is giving all the description about all the jobs and all. And coming to the stages, actually, we cannot run a particular job in a single stage. Okay, so there are certain kind of the stages where the job shuffling and all the submission, all these kind of the things, and storage. Okay, where it is getting stored. Actually, it is a in-memory storage. That's what we are not getting any information about that. And environment, the Spark environment. There are still we are having certain considerations. As I said, we are will make use of the cluster manager, and we are having the Spark contest and Spark session. Okay, all these kind of things we are going to talk. And no surprise for you guys, like this Spark also running on the Java, okay, JVM based kind of thing. Of course, as I said, the default application, the default language for Spark is Scala. Okay, so and there is no restriction. You can use either R programming, or you can make use of the Python, so as to handle. Even we are seeing that thing only. PySpark only we are going to talk in our implementations. And all these kind of the properties. Okay, all properties we may not use, but some of the properties we are going to talk in the discussion and properties. And if time permits, just you have a look on these kind of things, friends. Even whatever the cluster I have shared with you, just you can make use of those kind of the conventions. Okay. So just with this, yeah, some other aspects are there. Executors are nothing but the task implementers. Like how we are having our task tracker here. The executors are the machines who really runs the appropriate job. See here, the executor providing us how many blocks I am using, or how much memory. Disk usage is zero because there is no disk reference here. And of course, if any memory is not suited in RAM or cache memory, then definitely that will be spilled to this disk. That is kind. And cores, number of cores we are using, like how we are using number of maps and reducers. It is a similar kind of the core aspects. And if any failed tasks are there, or how many completed tasks, or something like that. Okay. So just we are how we have seen in mapper and reducer, a kind of parallelism, a kind of approach. Here also we can see, friends, the same approach, the same similar kind of thing. And here the approach of the garbage collector. Okay, this is playing a vital role because guys, if any application making use of JVM, definitely it is enjoying the benefits of that multitasking, multi-threading, or garbage collection, all these kind of the aspects. Okay. So just these things, the driver remains same. The driver here is a Spark context. I'll introduce all those terminologies in a while. Okay, but I thought of introducing these things practically so that I am showing these things. And most importantly, guys, in the job scheduling and in understanding of the jobs of the Spark, we are having one concept called DAG. Okay, directed acyclic graph. Okay, so what this does is, let me pick up one more job because it seems this job is failed. Okay, just our some of our guys submitted that job and it's not fruitful. Okay, so no problem. So just I will be selecting a job which is successfully completed so that we can show or we can see how this DAG is populated all these kind of the conventions. Um, Let me from Shell also they can submit no problem. But nowadays, all people are using Jupyter Hub only rather than going back to this shell. Here. Spark SQL they have used such a bigger job actually. It took around 43 minutes, big job. And here all the job IDs and all. Okay, so just you click on this is a stage information. See, this is the DAG friends actually. Okay, so the DAG visualization, what it does is just if you are making use of this DAG, which is providing a kind of the specification, like which are all the aspects involved in that, and what is the stage we are now. So all these kind of the conventions. So this really helps us to understand the job. Okay, and moreover, like that we're having many jobs, something like many jobs like this. So if I'm going back and selecting some kind of uh, somewhere, maybe I'm having two jobs here. If you click on this, see here how it is making use of the stages. Okay. So this TAG, what it does is a logical way of picking up the data, and it is going to establish a kind of the connection because while working with this Spark orientation, the appropriate aspects may be either in RDD or in the data frame fashion. And internally, we are having certain kind of the transformations and as well as the actions. And Spark, if you refer any blog or initially, if you are studying that particular Spark architecture, it is a lazy evaluation, friends. Spark is a lazy evaluator. That means whenever you are submitting or whenever you are giving some kind of the statement, it is not going to trigger immediately. Okay, it is not going to trigger the appropriate things immediately. Rather, what it does is it is making use of uh, all the packages, all the things required, it will be collecting. And whenever there is a need, whenever it need to reply or whenever it need to show something or display something or implement something, then only it is going to pick up all the existing things and it is going to give the result. Okay, that is what it is. It can be known as a lazy evaluator. Okay, like how people, especially students, before 2 days or 3 days of the examination, they pack everything and they collect all the material and they are going to prepare. Okay, that is lazy preparation. So just like that, this Spark also, the lazy evaluation, why that it is getting success? Maybe student may not get succeeded because within 2 or 3 days he may not able to cover the entire unit syllabus of the university examination. But Spark, the key success factor behind the Spark is it is triggering the appropriate actions whenever it is going to publish the result or implement something. So until that, whatever the transformations we're having, those things are not going to trigger anymore. So just they are keep aside, and whenever there is a requirement, then only it is going to uh, activate the things. So many aspects we are seeing here: jobs, stages, environment, executors, and moreover the appropriate DAG, which is directed acyclic graph kind of the notion. Okay, so here we are having certain um, uh, pathways, okay, how it is connected between multiple things. And here we are seeing map partition. Okay, these are all some of the terms and concepts or constructs we are going to use in the programming of the Spark. Okay, so with this, we can start with the relationship between Hadoop distributed file system and all those things. And moreover, let me show you some of the uh, some of the programmatical constructs. Okay, so just I'm introducing some of the aspects with you. The one of the barrier is, guys, just I need to give you the Python essentials also. So what I will do is today I'll use some of the constructs related to the Spark regarding with RTD and Spark session, Spark context, all these things. So you will be having some idea, okay, how we are going to achieve, or how we are going to implement the Spark kind of the functionality related to our requirement. Okay, so in the similar way, if you are considering in terms of MapReduce, Hive, Scoop, just we are having even lesser usage of the code. Okay, so let me show you how we are going to make use of this convention. Uh, just it is helping us. Okay, so how I'm making use of RDD and all. Sorry about that. Okay, I need to start it. 1 minute, guys. Jupyter Hub. Okay, from this particular thing only, we are having all these things. Cloudera Manager, Web Shell, Login Portal. These three things already we are habituated to use. Now we are going to the new zoner, this Jupyter Hub. Just it is launching, friends. So this Jupyter Hub is providing all the functionalities of accessing the Hadoop distributed file system, local file system, all such kind of the conventions. It is exactly like Jupyter Notebook only. Okay, you see all the interfaces, the same, whatever the interface I'm running. But on top of that, I'm having the Scala support also. Okay, so apart from the Python, we're having the support of the Scala, and moreover, it is a built-in. It is having the built-in Spark engine actually. In our Jupyter Hub, we only have support of Python-based packages. And if I'm requiring any additional package, I can install either at command prompt or in the Jupyter notebook itself. And some of the people in the call might have used the Google Collaboratory. That is also one of the best tool for Python programming and all these Spark practices, provided you need to explicitly install the Spark support package or Spark engine into our Jupyter notebook. The other option is, guys, whatever the this thing I have shared with you, virtual machine and all these things, they are a pre-installed Spark engine is there. Okay, you can use either Scala or PySpark. Okay, either of those things you can use. And moreover, keeping aside this thing, let me go to this thing, friends. 1 minute. Actually, while referencing this interface, web shell, through web shell also I can make use of the PySpark. And but generally, friends, the word count programs and all those kind of the submissions, alternative to the MapReduce, you can make use of this convention. Okay, but the most successful and compact version is the Jupyter Hub. But let me introduce this thing also, how we are making use of various constructs here. Have a look on this. Spark submit kind of thing. Just it is giving us all these aspects. How I can mess OC, Spark master, deploy mode, class, packages, repositories, PY files. Okay, all these kind of conventions. Okay, Spark standalone or mesos. Because sometimes I may run my Spark without any ad support. That you can use the Spark standalone. Okay, and deploy mode. I'll in a while I'll talk about all the things, guys. And moreover, just if I want to launch the PySpark orientation system, clear the yeah, Spark. Just to see this, guys. Immediately it is going to launch uh, the corresponding engine. Okay, the Spark engine it is going to give. It is connecting the Spark version and what is the Python version. All these kind of the conventions. Okay, so with this, just you can directly integrate either Python based kind of the coding you can run, or else you want to perform some kind of the activity in terms of PySpark, that also you can perform. Okay, so this is how we are making use of this thing, but very rarely people come to this command prompt. Um, and of course, all the aspects, whatever the things we are having, all those kind of the consideration we can achieve with the this thing actually in terms of Jupyter Hub. Okay, that is the basis for our learning. And moreover, I'll show you some of the things. How do we submit the jobs and how we can make use of the web shell? Okay, some people prefer usage of this thing also, friends. Some people may have this intention of using the command prompts and all. So for those guys, let me come out of this, share the screen. That is the PySpark. How we go PySpark is just to type this PySpark, which leads to access of the prompt, Python prompt, how you see in IDLE, the similar way you can observe. And it is providing us some instructions, how we are making use of Spark or Spark, PySpark, all these kind of things along with that. And moreover, if I want to run through some other aspect is there, Spark shell. So I'm giving like this. I have not mentioned which Spark shell I'm going to work out. Just it is giving some, yes. See, friends, here by default it has given that the execution into the Scala. We have not mentioned. That means by default the shell is established in terms of the Scala. A little programming. Just I am taking val RDDA. Don't worry about this thing. What I am doing, friends. Just observe that how we are making use of the convention. Uh, Let me see. SC dot. Yes, SC dot. Many are there. Spark context actually. SC dot. Uh, Parallelize of. Okay, parallelize of. Uh, 1 to some thousand values. I'm going to generate. Okay, it's parallel. Now I'm having some data in my value. Okay, so just if you are referencing this val, it is going to specify some kind of the consideration. Val dot select. Okay, all these kind of the count. Okay, whichever the means I want. Okay, so no problem. So just I'm introducing all these kind of the things to you guys. So just have a look on this and some some other aspects. Like if I want to store some kind of the data, like earlier we have stored the data in RTDA, no? So if I want to get the information about RTDA dot, okay, there are certain partition kind of aspects, partitions dot. What is the length of that particular partition by default? Okay, so two partitions are there. So where how we are seeing our Hadoop block system, it is also managing some kind of the partitions. So with this, just you can have a usage of the things and RDDA dot. Just I am collecting the data. So whatever the data we have populated, just it is submitting the job as you have seen job stages, executed, all these things. Okay, so this is one way of doing the programming with respect to this Spark specification. So now just I thought of showing you how do we make use of these kind of the conventions. Now coming out of this thing, let me clear the screen. And you may be having this doubt, how do I submit the job? Simple, Spark, just you can make use of shell. And I am explicitly mentioning the master as an and then my deploy mode. Okay, whatever the deploy mode my deploy mode is on client. Okay, so and then whatever the programming I'm having, I can give this kind of the configuration. Okay, so just you need to mention that how I am giving the Hadoop jar file, something like that. Just you can give this Spark shell. Your master is ARM and your deploy mode is a client mode I am deploying. Okay, just I want to deploy my job in the client mode, and you can specify the job category, maybe in WC.5 py or in the Scala orientation, whichever. Okay, so after submitting this particular job, how we are running our Hadoop cluster kind of thing, all those considerations, because as I'm using this AR actually, okay, how I have used in Hadoop MapReduce and as well as the Hive, it is also going to make use of that kind of the convention. Okay. So with this, we are having some kind of terminologies and concepts in our mind. Now, what we need to do is now we consolidate everything, and we are going to make use of the usage, how I am performing the activities, all those kind of the considerations. Okay. Just we'll jump into our discussion. So, as a consolidated aspect, what we have seen so far, let me summarize. Okay, then I'll introduce you how Hadoop is complement of Spark and how Spark is complement of Hadoop. Okay, so with respect to Spark, okay, so just we have seen some the Jupyter Hub. This particular Jupyter Hub is a combination of Python, Spark, and it is also providing Scala and Spark. Okay, these things I have seen. Uh, and thereafter, in the Cloudera Manager portal, we have seen this Spark component configured. So just to click on that, okay, it is having Spark Web UI. Okay, we're having the Spark Web UI. After clicking on this, just you will be taken to some uh, job ID, name of the job, username, status information, time. Okay, all these kind of the things. Suppose you click on this job ID 1234, it leads to some more interface. There I'm having the jobs, pages, executors, environment, like that. And here we observe the DAG, directed acyclic graph. So what it does, just it is providing stage one. In stage one, there are certain kind of the pathways to the job, and what exactly, whether this is map or whether this is reduce, whether this is collect, all these kind of the considerations we have seen. Okay, so certain terminologies we observed there, and this is of course all the information is available with the job history server of the Spark. And one more important point we observed, that is the first context, friends. The first context is the Jupyter Hub. The second context is web shell. From the web shell itself, there are two options. Either you can choose PySpark, okay, which leads to Python-based Spark programming. Okay, so just you can implement your PySpark kind of the logic. And second thing is, uh, so just in the web shell itself, if you type Spark shell, it leads to Scala actually. Lead to Scala. There we have seen some val, because in Scala you should specify either variable or val. In Python, no such requirement is there. So just I am introducing the context. Okay, val RDDA equal to, just I am using spark context dot some parallelize, which is a construct so as to generate some given information. Okay, 1 to 1000 numbers. And what we have seen, Scala RDDA dot collect. All the information will be displayed. Or else if I want to get some kind of the partition data, RDDA dot partitions dot length. It has given some two. So that means two partitions are there, and so as to implement that particular job, it is going to focus on those kind of the partitions. Okay. So with this, what I will do is let me show you that constructs in Jupyter Hub. Yes. Okay, we'll go back to this Jupyter Hub. Okay. See you guys. See here, guys. What exactly we are going to see. Uh, just to you observe, no problem. Again, we'll be back to this zoner. So the people who are having little knowledge in Python can easily pick up, but no problem. However, in the tomorrow session, I'll be introducing you some sort of actually these things, essentials of Python for Spark programming. So don't worry about that. Okay. So just there are certain terminologies where I am having PySpark.SQL, Spark session, and Spark session dot builder dot app name RDD get or create. Now, after importing this particular thing, if I want to observe what is the context of this Spark, let us try to understand this thing, guys. If you refer the kind of representation we are facing here, it is the reference of the Spark. This is the object actually. This is the Spark object where it is containing some kind of the basic information. Because what we have seen, the entire Spark session information related to our application is kept in is placed in the reference of the Spark. So at the moment you give this particular Spark, what it is saying, friends, the Spark session in memory, Spark context. Okay, I'll give you the distinction between, but just you see that what is the which are all the terminologies related. The very first thing is the Spark session, PySpark.SQL, and of course Spark session builder app name get or create. And if I'm getting the reference of that particular Spark, obviously we are going to see the representation in Spark UI user interface, which version I'm using, version 2.4.0, running on local machine. My master is local machine. Application name is RGD. Whatever the application name I have given, that is nothing but the RGD orientation. Whatever the application you want to do, you can use that. Similar to the earlier programming friends, like so in the programmatical aspects of Scala, what we have seen is in Scala, especially we have seen val RGDA equal to just how we have given val RGDA equal to SC dot parallels. But here what I'm using is Spark context. So there are certain distinctions between Scala and as well as the PySpark. Overall, the programming is same. Programming is same. But in the Scala orientation, I need not use the entire word Spark context. Rather, I can use SC. That is Spark context. Directly, I can make use of that one. Whereas in case of the PySpark, as this is not the native programming language, a little uh, detail is a little more detail is required. And parallelized, it remains same. Actually, I'm taking the data structure list here. Okay, so just I'm packing some kind of the numbers, and I'm going to store those numbers into the RTD. And thereafter, I am going to apply some kind of the constructs. Okay. So this is the basis for the understanding of the Spark reference. Now the point is how it is supporting your Hadoop distributed file system. Because we know that Spark, either with PySpark or Scala, or we can design some kind of the programmatical aspects, which is some sort of in-memory computing. Either you can use the local file system or you can go with the Hadoop distributed file system. Okay. Now, just to mention, I'm having some kind of the data with me, guys. Email input .xls, and if you go back to the home folder, and if you see this thing, right, just you see here, I'm having the email input .xls. This is not the Hadoop distributed file system interface. This is the local file system actually. So that's what the reason. Whatever the data we are. If you remember, friends, there we have seen some. We executed some university one, university two. Actually, these things are belonging to the scoop orientation, and I'm having the sales.csv and this reducer.py. Uh, all these things are available in our local file system. Even Hadoop streaming or employee SSE, employee SE. So just you go back to this and you observe. Let me come out of this Scala. So what I mean to say is our Jupyter Hub is running on top of the local file system. Okay. And moreover, after seeing this particular thing, if I am giving ls, whatever the things you have seen, all the things are available in our uh, Jupyter homepage. Okay, so just to see WHR, Worldwide Happiness Report. Okay, Yahoo stocks, everything here also, worldwide. So it is a built-in kind of thing. So our Spark is trying to access the local file system data, but here the thing is by default. Okay, by default, our Jupyter Hub is pointing to the Hadoop distributed file system. Okay, and slowly entering into the integration of Spark and as well as the Hadoop distributed file system. So, but my requirement here is, of course, my email input data is available in the local file system. Just now we have seen. Okay, here I'm having this email input data. And as I said, this is, of course, the representation of the local file system. Now, what we're doing, guys, here, just I need to mention the entire path. The entire path. How do I mention that entire path is file? Okay, path of the absolute thing. Just you need to mention, as I said earlier, every if you maybe if you are not aware of the file which is coming from, okay, because your Hadoop admin is not given the information about that, which file and all. But from the path itself, you can say that whether that file is from local file system or Hadoop distributed file system. If your path starting from home, slash home slash the corresponding user info, okay, whatever the information I'm having, just you can make use of, you can pick up that information. Whatever the data I'm having, I can pick up that data. Okay. So just as I'm mentioning home slash username slash the corresponding file name, every local file system file prefixed with the home. If you see in the path, if the home is a kind of prefix for that particular thing, then you can confirm that the data is from the local file system. Okay, so some data we got and we displayed the data with the collect method. Whereas you observe the second context, friends. Actually, in the local file system, I'm having the email input.xls, and in the Hadoop distributed file system, I'm having the email underscore HDFS. So for that, let us go to the Hue login portal. Okay, I'm having email. Let me refresh this. Actually, there is a distinction there actually. So I'm using the big data mind one, but in this example, I have used uh, the file system, local file system. I use the admin VM01. Okay, no problem. Whatever the file I'm having, let me see whether that email file is there or not. If that is there, I can make use of that. Otherwise, I can change that to email in or something. So what I mean to say is, if you are making use of your Hadoop distributed file system source, you need not mention the entire path. Okay, there is no requirement of the entire path. Itself, it is saying that if I'm not providing the entire path, what it means, friends? It means that, okay, it means that my default directory or default specification I am trying to access is the Hadoop distributed file system. Okay, just you have a look on those kind of the conventions and you can perform the activities. So, and moreover, as we are switching from local to PySpark and HDFS to PySpark, and in this case, friends, local file system becomes handy because in Hive also, if you observe, I need not go back and verify every time in the Hadoop distributed file system. There is a provision of loading the data from LFS, and of course, in a way, the table data can be stored into the local file system also. In similar way, okay, and moreover, one more important point I want to refer here is this Jupyter Hub, there is a provision of uploading the data, not only the IPYNB files, friends. IPYNB in the sense interactive Python notebook. Okay, interactive Python notebook, where all these generally Jupyter Hub kind of the extensions all are revolving around this IPYNB, and at times you may see this .py also. Okay, but especially if you are using the Jupyter notebook and these kind of the Jupyter Hub configured related to um, our PySpark or Scala implementations, the most preferable method is the IPYNB, which is a common practice and where this particular file can be utilized in either Jupyter Notebook or in the Jupyter Hub or Google Collaboratory or even Databricks also. I'll show that also, friends, in a while, but I don't want to overburden you. Only the thing is, just I'm slowly taking you into the genre of these terminologies and environment, all these things. Because the big data technologies, no matter whether you are working with Hadoop, Hive, Scoop, or else this Spark, getting into that architecture and understanding the terms is most important. And coding wise, only 10 to 15% we have to sweat. Okay, because after understanding how this architecture is and how we are going to submit the job and where this particular job is going and how it is setting up all the components, once you are having these kind of the understandings, uh, your coding won't give that much pain to you guys because by this time you'd have realized it's not definitely a heavy code. Uh, the advent of Python and integration of the Spark, all these things makes the life of data engineer and data scientist easier. Okay, so similar grounds, but only the difficulty is not writing the code or submitting the jobs or executing them, understanding the internals of the Spark and understanding the integration of the Spark and Python. Okay, so that is the basis point. Once you get into the architectural understanding and all the kind of the things, your coding becomes very handy, friends. It is quite simple in a single liner kind of thing you can achieve. Is a mix of Python and as well as the Spark kind of the programming. All those things I'll introduce one by one. Okay. So with this, just I'm stopping the discussion on the Jupyter Hub and all these PySpark. But I am consolidating all these kind of the terminologies in terms of Hadoop and as well as the Spark integration. Okay. The very first topic, guys, the very first topic, what I am talking here is how your Hadoop is going to integrate with the Spark orientation. Okay, so there is a myth actually. So there is a myth in the sense how these kind of things are reciprocating, or how people are seeing Spark and as well as the Hadoop. That is probably the most important topic we need to describe. So the concept here is already I'm having the idea of Hadoop distributed file system and all these conventions. Now my idea is how do I make use of that Hadoop in my programming of the Spark? Okay, so while representing those kind of the things, let me pick up some. Actually, I have compiled some aspects for our discussion. What I'm doing here is let me pick up what Hadoop gives to Spark. So just I'm getting the content for us, guys. This is the first thing, and next next is what Spark gives to Hadoop. Okay, both the things we need to discuss. Right. So this is the best point where I can start. Okay, because already we are having the notion of Hadoop ecosystem. So basis on that, it becomes easy for us because uh, known to unknown always there is the best strategy. But human life is unknown to known actually. We are not knowing ourselves, we are traversing to know ourselves, unknown to known. But knowledge, all these things are known to unknown. On the basis of the known things, we are building the unknown aspects. Okay. Now, what Hadoop gives to Spark? Reasonably, Spark, we're having some idea now, which is also a kind of job submission tool and which is supporting Scala and as well as the Python. That much we know, and that is enough actually. And moreover, we have seen some in memory. Okay, that understanding becomes very clear once I complete the Spark architecture. But immediately, I don't want to give the in memory or all these understandings. But let us clear all these surroundings, and then we'll jump into that in memory. And within that, we are having jobs, stages, tasks, and sometimes these tasks are also known as executors. These things we have seen, and most importantly, Spark context, Spark session. Okay, right. Now let us see because Hadoop we know Hadoop is a combination of HDFS and MapReduce. Our HDFS is for the sake of the storage, MapReduce is for the sake of the processing. Okay, now Apache Spark is often deployed in conjunction with the Hadoop cluster. As I said earlier, na, Spark on top of the add, I can execute. Though Spark is having the native cluster management or cluster resource management tool called Mesos, but that is a somehow it missed out the uh, magic, guys. So it has not accepted or it has not uh, taken by the developers. Okay, because it's a simple point. Suppose if you are having the Java knowledge, it becomes quite handy for you to learn Hive or MapReduce or Hadoop distributed file system, all these things. If you are and if you are having Python basics also, then either Hadoop is easy or you can venture your learning on this Spark also. So the people don't want to leave their whatever the technology they're adding. That is not required also. In fact, so on top of the technology, if you are building your further So if you are building further, then obviously it becomes easy for you, and in a way you are keep in touch with the existing technology what you are having, and maybe in future if we are getting the projects related to this advanced technologies, your capabilities are quite meeting to our expectations. Okay, so now this and however I know how to submit the job in Hadoop, and how to submit the job in not Hadoop, how to submit the job in Python, and how to submit job in Java. So in Spark also related to this ad, either I can submit my job in Scala or else in Python. Either way. Okay. So Apache Spark is often deployed in conjunction with the Hadoop cluster, and Spark is able to benefit from number of capabilities as a result. Okay. Can someone give me what is the advantage of this ad, friends? Only one or two. You can use the chat window because now onwards I can make use of your consents also, because earlier you are completely new to that technology and terminology, so that I never get a chance of asking some questions on top of that. Now tell me guys, okay, because here the number of capabilities as a result, I am asking you, can you give at least one or two? Two if you are giving, I'm happy. I'll stay back here. So can you give two benefits or two advantages of this ad? Let me type in the chat window. Okay, very good, Sahul. Uh, and benefits. So in terms of programming, that is you can. I'm just giving the hints. And in terms of resource management, uh, these things there. Sai Santosh says, Air Melo's job submissions like very good. Actually, this is excellent point. Okay, why Air is becoming more popular is see friends in life also, how many technologies you know, how much network we are having, these things really define us in the appraisals and all these things. The technology is also not there is no excuse for the technology also. Okay, so similar to how we are learning and how we are making use of our lives to venture the jobs, these Spark and all these kind of the techniques also, as many technologies are supporting. Okay, so ARN actually in the discussion itself we have seen ARN is ARN opened some kind of the new avenues for the integration of the various programming languages. Maybe that earlier MapReduce one only that limited support, and there is no integration for other programming languages and all. But whereas if you are talking about the ARN introduction, okay, it is still supporting the MapReduce, but also it is allowing us to perform some kind of the activities with Storm, and it is creating some kind of the placeholder to integrate Spark. Okay, such kind of extensions are there. Any language which is having the extension or integration support never dies. Okay, so starting from Java, Python, Scala, up to the level of Spark, every constructor. Okay, if there is a possibility of the integration, if it is ready to perform some kind of the activity, then obviously we are making use of that convention. Okay, so that is the observation. And other things, the efficiency of the system is increased with the usage of the AND. Yeah, it is quite indirect answer actually. Okay, Harry says only three members are there in the call, all are sleeping or what? Okay, so just you at least you give some convention things. Okay, I'm not asking many things. Okay, just at the time of asking the questions, try to give the answers. Okay, it is always better to have that rapport. Hmm? Just passively don't spend time. Whenever there is a requirement, whenever there is a possibility, just you give that answer. Right? So the efficiency of the system is increased. How efficiency increases is various factors we have seen. Efficiency in terms of speed and efficiency in terms of space utilization. Okay, and moreover, at the time of MapReduce one, it is quite a batch kind of thing. Whereas ARN is providing some iterative kind of the jobs also. Okay, those kind of things you can see. Multiple MR slots, yes. Okay, while running the jobs and while performing the activities, all these zoners we have seen, friends. Okay, the same advantages. Okay, leverage up to the Spark also. The capabilities, if you observe, as our friends mentioned, support of Java, support of some kind of the Python, all these things, and power of running, maybe in terms of time and as well as the space, all these kind of the aspects. And now, if you are considering the integration of the ARN and as well as the Spark, ARN acts as a resource manager to Spark. Spark need not worry about how to handle the resources and all, because ARN is the one of the best tool which is providing the better resource management. Most importantly, the distributed file system. Friends, here, though Spark is not completely dependent on the Hadoop distributed file system, but the advantage of the distributed file system is replication and as well as reliability of the data. Okay, all these things. And moreover, the time required to perform some activity. Maybe if you observe, guys, uh, if you are making use of the long back, we have seen this while starting the Hadoop distributed file system. If I am giving a reading of 1 TB of the data to one machine, it took some 45 minutes. Whereas if I'm establishing a distributed file system with multiple machines, assume that some 10 machines has been integrated to the task. Uh, so automatically that 45 becomes 4.5 minutes. So direct proportionality. So the distributed file system directly reducing the time factor while performing the jobs or activities. And this thing, friends, this is quite interesting. Disaster recovery capabilities, single point failure, and if you see the speculative execution, most importantly. Okay, because Spark is not meant for the storage. Okay, Spark is meant for the processing actually, processing of the jobs and all these kind of the things. So here the most relevant context is disaster recovery in terms of speculative execution. Speculative execution, pretty good we know. Like I'm having multiple jobs in my hand, and those particular jobs are performing some kind of activities or tasks. And meantime, some of the tasks unable to make use of the data, and it is unable to respond back to the master properly. Then what is the solution for that case? Again, the master should establish a new task tracker or maybe the new node manager, and it is giving some sort of okay, whatever the failures or whatever the lagging. We cannot say that as a failed job, but there are certain laggings in the stipulated time. That particular node manager is unable to update the info. And if you are talking in terms of ad, there is a application master actually. There is a clear distinction between application master and as well as the node manager. Node manager conveying the information about the hardware in the sense whether machine is available or machine is ready to implement some task, all these things. Whereas if I am talking about my application master, it is purely talking in terms of job orientation, map task, reduce task, how much amount of the job is completed, Only those considerations we can observe. Okay. So the disaster recovery capabilities in terms of speculative execution, as Spark is running on top of the AM, the same while running the Spark job, if something happened, if any problem is there, then obviously that will be taken care by the AM. So that is what how you can recover the jobs without fail, without any problem. A distributed data platform, as usual, if you refer the usage of the ARM obviously running MapReduce jobs. In turn, MapReduce job is only knowing about the Hadoop distributed system or Hadoop distributed file system. And if at all you also want to run your Spark job on top of the ARM, and if you want to make use of the Hadoop distributed file system, it's not mandatory, friends. Just now we have seen, like in our example of Jupyter Hub. Okay, so there what we have seen is either from the local file system you can make use of the appropriate job orientation. Okay, otherwise what you can do is with the notion of okay with the usage of this Hadoop distributed file system, I can perform the activity. So in either case, just if I'm mentioning, if I want to go with local file system, just I can mention this way. Okay, so text file, just you mention the path and give the local file system. And whereas if you want to scope Hadoop distributed file system, and of course we know that especially our cluster, this may not always be the case, friends. But this Cloudera cluster which we are using, this cluster is running on top of the Hadoop distributed file system, so that you need not explicitly mention the appropriate data. So, but whereas, for example, so let me do this. How do I mention this orientation in the distributed file system manner? So, just I can create one more cell. Just you see here, guys. What I'm doing is assume that if I am not using by default the Hadoop distributed file system, just I need to mention user, and here I should mention big data mind one, and whatever the content I'm having. And I should get the content from Hadoop fs-ls. Let me see whether they have configured for this user, because generally admin VM01 is having the access. Let me give it a try, no problem. So just I'm having the sales one data, friends. Okay, just I'll be going back here. Um, just I want to make use of the sales one data. Okay, so actually I need not mention this entire path. Rather, what I can do is uh, just let me put this in commenting, and just I'm saying that. So how a particular Spark workspace can be utilized so as to mention, so as to get the corresponding data from the Hadoop distributed file system. So context dot text file of directly you can mention the sales one. Okay, so files must be in Python especially, just we have to give that double quotes or single quote. So with this, as this cluster especially is running on top of the Hadoop distributed file system, which is configured with the add directly we have mentioned. Otherwise, what you can do is just as usual, how we are mentioning your home slash username and file name. Similarly, here also, just to mention the file colon three slashes user. Okay, it automatically becomes your HDFS. Okay, because the default prefix for the Hadoop distributed file system path is file colon user slash the corresponding user information and the file name. Okay, so Likewise. So now, if you are seeing this convention, why we are here is because that particular Spark engine, whatever you are making use, it can enjoy the benefits of the distributed data platform. It can enjoy the benefits of the distributed data platform. So, in the simplest way, you need not be a pro in Spark, but if someone asks, okay, as you have done some kind of training on Hive or Scoop and Hadoop distributed file system and MapReduce, and in what way you are eligible, or in what way you can make use of, at least make use of the existing Hadoop knowledge into the Spark. The first and obvious context is usage of the app resource manager. And second thing is the distributed file system, because the Spark can enjoy the benefits of that distributed file system. And as it is running on top of the air, obviously you can manage your speculative execution, single point failure, all these things. Because if you are doing friendship with a good person, friends, like who keeps the team alive, and who is having the mentality of willingness, and who is a continuous learner. Some or other way, 5 to 10% properties will come to you also, because as you are spending with your team member majority of the time, and in his body language and in his way of implementing the things, definitely we can get some of the aspects into you also. Similarly, the technology also, while integrating, okay, these kind of aspects, you can make use of this convention of disaster recovery, single point failure, speculative execution, all those things. Okay. So with this, just we can, this is the first important point where we are estimating our Spark capabilities to Hadoop. Because Hadoop itself is a giant in big data technologies. And if I am going further, and if I want to leverage the functionality of Hadoop technology in terms of the Spark, that's what exactly we are doing. So, so far, whatever the discussions we have done in this session, helpful to revise our potentiality in Hadoop ecosystem. Second important thing is how the Hadoop environment helping the Spark orientation, and which are all the terminologies related to the Spark. Okay, these three genres we touch base. Now this is the aspect where we are stepping into the understanding the capabilities of the Spark in terms of big data Hadoop integration. Okay, so see here, just you if you observe this point, guys, since the introduction of the AND resource manager, Hadoop is now better able to manage a wide range of data processing tasks, from batch processing to streaming data and graph analysis. Observe, guys, here, Hadoop, if I'm saying, it's not only the Hadoop distributed file system or map reduce, it is but also it is ecosystem. Maybe I'm having Kafka, maybe I'm having Flume, might be Spark. It goes on, the list goes on. So, because the capability of this particular Hadoop become now a unified methodology because of the AND that we pretty know. Because earlier Hadoop is distinct, after the advent of this AND, is its profile has been changed completely. Okay, so while using many kind of the technologies, your ARM is the first mark winner. Okay, where this ARM is allowing the integration of all these tools. Earlier, it was not that nice. Okay, earlier it's not like it is like only very stringent map reduce one. You have to think in terms of mapper and reducer. Okay, because no other different programming, and of course your badge, all these kind of the conventions, it becomes now interactive and iterative. Okay, so without any doubt, Hadoop has been leveraged from batch processing to not directly, indirectly streaming data in terms of Kafka. and as well as the graph analysis. Okay, some visualizations, all these things. Now, how Spark is, in what way Spark is helping our Hadoop? That is the question actually. Because in this point, again, we are reiterating the Hadoop context only. We are not doing any much in terms of Spark, but we are again iterating the context of the um, Hadoop only, right? Okay, now observe the first point, friends. In the beginning of this session, if you remember, I have given one word called MLlib, which is famous and which is in fact the basis for every data scientist. Okay, so Spark's machine learning module delivers capabilities not easily exploited in Hadoop without the use of the Spark. And the problem here is, friends, um, uh, while working with Java also, in terms of strings, in terms of JDBC and abstract windowing toolkit, or some sort of event-driven programming like listeners and all. If these things are not there, friends, just assume that how big we need to write the coding and all, because JDBC, if it is not there, again we have to write a native code for Oracle or SQL Server, and lot of configurations we have to do. Then only there is a possibility of establishing a kind of the communication between database technology and with your Java. So in a similar way, if with the help of this Spark MLlib, okay, because Hadoop is no more not having any interest on the analysis purpose, friends. But Hadoop can be used, okay, with the help of the Spark. Okay, as I said, suppose I'm having some reviews of five of my friends. There could be a bias result. Bias in the sense, out of these five, three members are fan of that hero, and two members are angry on me because I have not. I have not said yes to come to the tour or something. We planned some tour, but I denied the tour due to some reasons. These two guys are angry on me, and the movie is worst, and still they want to take revenge on me. Just they said that the movie is awesome. It's a biased one. And these three guys out of five, fan of that hero, of course, if they are fan of that hero, if he is doing something nonsense also, they like. So total five are biased result. Rather, what I can do is I can simply go to the Google reviews or else some other book by show how fast these particular tickets are filling, and certain genuine reviews if I am going is a bulk data actually. Why I am saying this point is rather than five records if I am using to analyze my data, okay, if I am making use of some records, thousand records, and the analysis is definitely better than the first one. So here, what we are doing here is, guys, your Hadoop is very good in storage, but you don't know how to use this particular storage for the better way. And with the help of this Spark, with the usage of this ML library, one can easily achieve the analytics and better usage of the patterns and better understanding of the internal aspects of the data. All these kind of the conventions you can observe. Okay, so that is the very first point where you can observe the capabilities of the Spark given to the Hadoop. Okay, so this is pretty clear, guys. Second thing, second thing is giving all the narration what exactly the capabilities of the Spark. Have a look on this, guys. Spark's original design goal is to enable rapid in-memory processing of sizable data volumes. Sizable data volumes in the sense the volumes can be adjusted. Okay, adjusted in the sense sometimes I may pick up a sample of the data out of 1 GB. I can pick up some 100 MB data, or out of 1 TB. I can pick up from 10 GB of the data. So the sizable volumes, okay, adjustable or sizable volumes, which is also remains important contribution to the capabilities of the Hadoop cluster. Guys, Hadoop cluster completely works on top of the block storage. And if such kind of the block storage I'm using, and along with this sizable volumes, so accordingly, Hadoop can provide the appropriate block storage, and on top of that, Spark can leverage the functionality of that. Okay, so this is the second important thing. That means its original design goal is not to use the disk-based access or disk-based storage. Rather, with the RAM or with the in-memory kind of the processing, the appropriate data volumes can be handled. And of course, which also remains the important contribution to the capabilities of the Hadoop cluster. Hadoop cluster, however, is a proven technology for bulk data storage and processing that we have seen. The same kind of the approach, okay, with the support of the Spark, Hadoop can make use of that block storage efficiently while processing while supporting to the Spark. And most importantly, friends, streaming is not the capability of the Hadoop. Okay, because Hadoop, though we are having ecosystem tool as Flume, not the live stream. That is, to be frank, only the thing is just what I can do is I can make use of some Twitter data, and of course with Scoop, how we have done picking up the data from MySQL to our Hadoop distributed file system. In the similar way, what I can do is I can fetch the data or live data only. I can fetch the live data, but that live data again will be stored into the Hadoop distributed file system. Okay, that is the real data only, but not the live data. So there are certain 10 minutes or 15 minutes streaming delay would be there. Uh, Accordingly, you can get the pulse of the customers or pulse of the members who are posting on Twitter, maybe from past 20 minutes. What exactly the trending word in Twitter? Okay, of course, except Elon Musk. Elon Musk is a all-time trendy person. Okay, in Twitter, of course, that is by default. Apart from that, any other trendy aspects or technologies or persons or any places or any events, all these kind of the considerations, right? Okay. Now, finally, one more capability. So, with this, just we can take a break here, guys, and then we'll come back and discuss some of the things what we are going to do in tomorrow's session and what exactly the leftover aspects, all these things I'll be discussing. In certain circumstances, Spark SQL capabilities. Excellent topic, guys. This is Spark SQL. In fact, I'm going to give some kind of insights of that. Spark capabilities. The very first thing is we should mention Spark SQL. This is the first thing. And second thing is streaming actually. Streaming capabilities. Spark streaming. Of course, with Kafka. And thereafter, what we are seeing here is graph processing capabilities may also prove to be of value in enterprise use cases. Okay, graph processing very rare because especially the Facebook kind of the guys and where they want to visualize the flow of the data and all these things. But generally, uh, the visualizations, all these things are pretty well in case of Matplotlib and Seaborn library frames. Okay, in the Python essentials, however, I'll give you a glimpse of those packages where you can make use of that convention in the understanding of visualization technique, all these kind of the considerations. Okay. Now, just with these three kind of things, what exactly the Spark SQL? Yes, in case of the SQL orientation, to talk about this Spark SQL, whatever the SQL constructs I'm having in terms of group by, in terms of select, where class, order by, views, everything. Okay, all these kind of the things you need not unlearn. Okay, because the guys who are very passionate about SQL and who are having reasonable uh, analysis, analytical knowledge on that window functions and all, they can very much enjoy this Spark SQL zone upgrades. Reason is you are already aware of this SQL. So simple as it is the whatever the statements you are having in terms of SQL, you can venture the same kind of aspects in Spark also. Okay, that they named as a Spark SQL kind of thing, which is a bigger relief for MapReduce developers actually. MapReduce is a kind of the complex program, friends. No doubt about it. It's a complex programming. Of course, alternatives were there in terms of Hive, in terms of Scoop, in terms of Pig Latin. Like that, we're having some alternatives. But still, that particular thing is not completely into the SQL orientation. So by SQL and Python still required for the entire projects, no matter whether that is a Databricks or data services and data engineering, data science, Uber, all these kind of the clients or all these kind of the projects, the minimum requirement is Python and SQL. Okay, so with this kind of the Spark SQL, however, we are implementing these things with the help of the PySpark only. So in a way, you can make without any additional technology, with the reasonable knowledge in Python, with the good knowledge in SQL, you can write, you can submit excellent kind of the jobs and coding related to Spark SQL. Okay, so it is the way of simplifying the complex code into the very less kind of the codes. That too in SQL orientation, SQL construct. And one good news here is, guys, like whatever the Spark RDD or data frame you're using, and you are completely not using any RDD or data frame, but you are devoted to your SQL, there is no time or space distinctions. I mean to say, whatever the performance we estimated in terms of a typical Spark RTD and data frame, the same kind of the performance is achieved in Spark SQL also. Okay, so Spark SQL also provides some kind of the constructs and all these things will be handled and without any deviation, because again the problem is Spark is providing some high-end RDD and data frame, and but you are not complete aware of those kind of the concepts, at least in the initial days of the project. But you are well familiar with SQL, and maybe it is very easy for you within a week or 10 days. You can directly get that Spark SQL inputs, and you can you can involve in the projects. The sometimes guys, if I'm making use of Hive, Scoop, or Piglatin, they are not going to compete with your MapReduce capabilities. MapReduce is faster, no doubt about that. Comparatively, with Hive, Scoop, or Piglatin, MapReduce is faster because again there is no need of conversion of that Hive into MapReduce to the lower end. Not like that. MapReduce is directly hitting the cluster and it is going to run. Similarly, in case of the Spark SQL, okay, there is no distinction. There is no performance pitfalls or laggings when compared with RDDs or data frames of your PySpark. In what way you estimated the time and as well as the space kind of the performance, the same kind of the measures remains continue with the Spark SQL. Okay, so that is the advantage. And streaming wise, streaming I will give you a case study, guys. Maybe just you can prepare that Kafka case study I'm having. Just I'll be giving that. Just have a look on this. That is the thing. And finally, the graph, of course, they are all used by some kind of Facebook and all. But definitely there is a heavy programming involved. Okay, so in this discussion, guys, what we have observed is The capabilities of the Spark, okay, empowers the Hadoop in the first term, machine learning library, ML library. Though Hadoop is having the capability of holding heavy data, but it is not meant for the analysis. But one important aspect is for the analysis, if I could make use of the big data or huge amounts of the data, then I can expect better results. That is the first thing. Second thing is how Spark is syncing with Hadoop. Hadoop cluster is having its own block-based kind of the storage, and the similar kind of the approach can be integrated with the Spark orientation, as that is supporting the in-memory computing, and where you can make use of your data volumes in a sizable way. That is the second thing. And coming to the third option, in certain circumstances like Spark's SQL capabilities, streaming capabilities, and graph processing, all those things may also prove to be the value in enterprise use cases. Enterprise, in the sense, guys, set of departments or all the departments together. Suppose in our company, so just we are having many sub department, many BUs. Maybe data services is one thing, and Databricks is another thing, and Uber is another aspect. Trim, like that I'm having different zones. If I'm making use of Spark, okay, some or other way, Uber is requiring data engineers and data analysts. Databricks is requiring data engineers and data analysts, and as well as our uh, this thing is also data services is also requiring all these things. Okay, so this becomes one enterprise actually. We are not limiting to one client or one kind of the project, but our capabilities are running on top of across these kind of the projects. Okay, so just now we concluded how Hadoop is helping Spark and how Spark is helping Hadoop. So now you can conclude a simple uh, uh, thing, friends. Like there is no harm. Okay, there is no problem. Even Hadoop is there or Spark is there. Ultimately, the appropriate aspect is how we are making use of the storage and as well as the processing capabilities. Okay, that is the main important consideration. So before taking the break, just let me give some few aspects. Okay, so just I'm making use of this particular thing as a conclusion before having the break. Within 2 minutes, we'll have a break. Just have a look on this. So far, I did not mention any definition or some kind of context of the Spark. We were talking about what exactly Spark is and which are all the terminologies and how Hadoop is integrated, how Spark is integrated, those things. But now, just I am giving the introduction of this particular Spark. Is a cluster computing framework for large scale data processing. Simple. Okay, is a framework actually. This is also a framework as that of the Hadoop. That's what we are learning in the big data tools. Large scale data processing, huge data processing. Okay, so is a cluster computing framework. What do you mean by cluster computing? Cluster means nothing but group of similar machines, friends. So if I want to run some e-commerce application, if I want to know the market basket analysis of the corresponding customers and to understand the buying habits of the customers, just I want to preserve. I want to make use of these kind of the conventions, like so the machines, all these machines are grouped and they are working for a particular application. Okay, all these things. Okay, so I am stopping here. So just I have introduced the definition of that Spark because if someone asks you what is Hadoop, you can say a framework which provides HDFS and MapReduce. Spark, which is a cluster computing framework that is for the sake of large scale data processing. That's it. And further, if they ask also, Spark is having two basic constructs that is Spark RDD and Spark data frame. And Spark supports PySpark, Scala, and Spark SQL. These many kind of the programmings. Okay. So with this, we can stop here, guys. I'm waiting for you. If you are having any doubts, please let me know.